Good morning, children. So, in the last lecture, I discussed the last topic was work done in cyclic process, and we have done it already. That if you take a system from the initial state A to the final state B, first through the path 1, then through the path 2. That's why you see I have written A1, B2A. We obtained in the last lecture, it was the last topic, that work done is equal to area of this enclosed graph, and it was plus. It means that work is done by the system. Alright, now we will do this. Suppose instead of taking it from A1B to A, means instead of taking in the clockwise direction, you are taking the process, cyclic process, in the anti-clockwise direction. So, means you are taking it from A to B 1A. Is that clear? You are taking it from A to B and then from B1A. So you can break that entire work done into two parts, A to B, and then it from B1A. Is that clear? So when you are taking it from A to B, according to our concept, what will be the work done? If you draw perpendicular from A to B, then the enclosed area, means you can write. And in this case, when you are taking from A to B, the volume is increasing. So work done will be positive, and which area, if you draw the perpendicular and if you name it as CD, then you can write area of A to B D C A. Means this area, A to B D, then C, then A again. Closed area, be careful. Then next is what will be the work done? B1A. So B1A means, look at it, what is happening to the volume? Volume is decreasing. And we know that in case of thermodynamic work done, when volume decreases, work done will be negative. So there will be a negative sign. And what will be the work done from A? You are taking this path. So if you draw perpendicular, then it will be this entire area. Alright, means you can write it as area of B1A, B1A, CDB, CDB. Is that clear? So, you see, if you consider this entire area, the bigger area, and subtract this smaller area, what are you getting? Again, you are getting area of A1, B to A. Means again you are getting the area within the closed graph. Alright. But here, look at this one. The bigger area is negative. So what will be the sign of the total work done? It will be minus area of A1, B to A. And when the work done is negative, then it will be work done on the system. Means somebody else is doing the work and work is done on the system. And when work done is positive, then who is doing the work? The system itself doing the work. So you have written work is done by the system. This concept you have got in 10th standard only. What is the meaning? By the system, on the system. Okay. So we are repeating the same concept. So in this case, you have to understand that it is same cyclic process, but when you are carried the cyclic process clockwise and when you are carried it anti-clockwise, then what is happening? Although amount of work done is same, area of the enclosed graph, area within the enclosed graph, but when it is clockwise direction, then work done is positive, and when work done is carried in the anti-clockwise direction, system is taken in the anti-clockwise direction, then work done will be negative. So these are the main important point of difference between work done in cyclic process, and you must learn and remember it. Then coming the concept of internal energy of a thermodynamic system. As you know that thermodynamic system is consist of a very large number of molecules, and you know that molecules possess both kind of energy, kinetic energy and potential energy. So, if you consider the kinetic and potential energies of all the molecules present in the system, that will give you the internal energy, measure of the internal energy of the system. Alright. Now, internal energy of a thermodynamic system, it depends on the state of the system. Alright. Suppose if you change the state of the system, means you are taking the internal energy from one state to other, then what will happen? Internal energy will change. But just consider the cyclic process. Cyclic process, what we do? We take the system through a cyclic path and we take the system through different change in state, but finally we get back the same initial state. So in case of cyclic process, what is happening? The system is coming back to its initial state. So what you can say, that during the cyclic process there is no change in the state of the system. Alright, it is undergoing change but ultimately coming back to the same initial state. So what is the overall effect? Overall effect is that there is no change in the state of the system when the system is undergoing cyclic process. So during the cyclic process you can conclude that there will be no change in the internal energy. Why no change in the internal energy? Because internal energy, it is a unique function as it depends only the state of the system. How the state is achieved, it does not matter. Okay, how you are changing, what parameter you are changing, and you are changing the state, you are achieving a new state, that does not matter. Internal energy do not depend on it. Internal energy only depends on the state of the system, means the particular value of all the parameters at that moment. Okay. But you know that when you change the temperature of a substance, temperature of a thermodynamic system, then what will happen? Change in temperature happens when there is a change in kinetic energy of the molecule, and you know that as internal energy is sum of the kinetic and potential energy of the molecules of the system. So if the temperature of the system changes, then there will be a change in the internal energy. But if the temperature of the system remain constant, then what will happen? There will be no change in the internal energy. So these are the important points you have to remember regarding the internal energy. First point, internal energy is what? It is the sum of kinetic and potential energies of all the molecules present in the system. Secondly, internal energy does not depend on how the state is achieved. Internal energy depends only on the state of the system. If there is a change in state of the system, internal energy will change. Is that clear? Again, internal energy depends on the temperature of the system also. If there is a change in temperature of the system, then what will happen? Internal energy will change. But in cyclic process, as there is no change in the state of the system, at the end of the process, the system get back to the initial state. So during cyclic process, there will be no change in the internal energy. So internal energy is a unique function as it depends only on the state of the system. So you must remember the concept or all the points just now I have described related with the internal energy of a system. Next is coming this concept, just try to understand. Suppose one system was at the state A and then you are taking it to the state B. Means A is the initial state. A is the initial state of a thermodynamic system and B is the final state of the thermodynamic system. Now what you are doing, you are taking it from A to B following, you see the system from A to B following the path 1, isn't it? Now when you are taking it from A to B, then certain amount of heat will be associated with the system. So let us consider Q1 heat is given to the system for this process. So to take the system from A to B, certain amount of work has to be done. Let us consider W1 be the work done. Okay, when you are taking the system from A to B through path 1, then Q1 heat is needed for this process and W1 is the work done in this process. Let us consider somebody else has taken it from A to B following path 2. And when it has been taken from A to B following path 2, then Q2 be the amount of heat involved within this process, and W2 be the work done. Let us consider someone has taken it from A to B following path 3. And for the path 3, Q3 be the heat associated with the process and W3 be the work done. Someone else has taken it from A to B following the path 4. And let us consider Q4 be the heat associated with this process and W4 be the work done. Okay, W4 be the work done. Alright, this is for path 1, this is for path 2, this is for path 3, this is for path 4. Alright, now it has been observed that if you find out the difference between the heat associated with the process and work done, it is always remaining same for all the path. I repeat, although the heat needed and work done, they are different for different path. When you are taking the system from same initial state to same final state but following different path, then what is happening? Heat needed and work done, although they are different, but the difference between the heat and work done is constant. This equal to constant. And this difference between the heat and work done represent the change in internal energy. You know that delta represent the change. Sometimes we write it like this also, du. Okay, this is used in calculus. D means the small change. When the change in the internal energy, U stand for internal energy. When you are writing delta U, delta represent the change in internal energy and du represent the small change in internal energy. In a very simple way, you can understand it. When you are giving heat to a system, what actually you are giving? You are giving some energy to the system, isn't it? So, by utilizing that energy, the system is doing some work to move from point A, initial state A to final state B. Okay? Means, suppose you have given Q amount of energy, a part of it is used to take the system from A to B for the work done. Is that clear? So what will happen to the rest of the energy? Rest of the energy will increase or will change the internal energy of the system. Alright. This is the concept of the first law of thermodynamics. So what is the first law of thermodynamics? This is very important for your exam, all kind of exam, that if in a process, dq is the amount of energy given to the system and W is the work done by the system, then change in internal energy du of the system is given by du is equal to gq minus dw. Alright. So, this one can write it as dq is equal to du plus dw. So, you can write this way also. Either you can write du is equal to dq minus dw or you can write dq is equal to du plus dw. Alright, means what? When you are giving this much of energy, heat energy in the form of heat to a system, then out of that given energy, a part of it will be used up to do the work done in order to take the system from one state to other, and rest of the part will be utilized to change the internal energy of the system. Alright, so it is better to remember the first law of thermodynamics in this form, that dq is equal to du plus dw. The statement of the first law of thermodynamics and this mathematical relation everybody should practice, learn and remember for your exam. Now, we have to learn how to apply the first law of thermodynamics in different processes. But if you want to apply that, then you have to remember the sign convention regarding the energy, heat energy, work done as well as internal energy. I hope you can remember that when heat is given to the system, heat is absorbed by the system, then the Q will be positive. And when heat is given away by the system, when system is releasing heat, then Q will be, dQ will be negative. When work is done by the system, how you can find out work is done by the system? Volume will increase. Then dW is positive. When work is done on the system, means volume is decreasing. In that case, what will happen? dW will be taken as negative. Like that, for internal energy, GU also, what is the sign convention? If the internal energy increases, then DU will be positive, and if internal energy decreases, then DU will be negative. Alright, so before applying the first law of thermodynamics, everyone should keep inside the brain the sign convention related with GQ, GU and GW. Okay, then only you will be able to handle the next topics. So let us first apply the first law of thermodynamics in cyclic process. Cyclic process means what? You are going back, you are taking the system through a cyclic path, through a closed path, and you are going back to the same initial state. Alright, so for cyclic process, first point is as initial and final state is same. Alright, initial and final state is same. What will happen to the change in internal energy? Zero. Because internal energy depends on the state of the system. Alright, you are taking the system to the same state. So no change in the state. That's why internal energy du is equal to 0. Alright, now according to first law of thermodynamics, this is according to, I hope you know. First law of thermodynamics, what you can write? You can write dynamics, what you can write? That dQ is equal to du plus dW. So as du is 0, so you can write that dQ is equal to dW. What does it mean? When dQ positive, then dW positive. What does it mean? What does it physically mean? This is mathematically I have written that dQ positive means dW. What does it mean? When heat will be given to the system, heat is given to the system will expand, volume will increase. The system will expand, volume will increase, and work is done by the system. Work is done by the system. Is that clear? Then what will be the, here there is no place, so I am writing the point here. After this it is coming that if you consider that dQ negative, according to this relation, if dQ is negative, what will happen? dW negative. What is the meaning? This is the mathematical one. What is the physical meaning? Physical meaning is when heat is released by the system. Heat is released by the system. Then only no dQ is negative. Alright. The system will contract. The system will contract and work is done on the system. Alright, volume of the system will decrease and work will be done on the system. On the system. Here work is done by the system. And the system expand. And in this case, the system contract. Alright, so this is the way by applying first law of thermodynamics you can make these conclusions for the cyclic process. Okay, please do learn and practice it. Next, if you apply the first law of thermodynamics was isothermal process. What is isothermal process? The process during which the temperature of the system remain constant. So already while discussing internal energy, I told you that internal energy depends on the state of the system. It depends on the temperature of the system. If the temperature remain constant, then what will happen? There will be no change in the internal energy. Means what? As temperature is constant, no change in internal energy means du is equal to 0. So what will happen as dq is equal to du plus dw according to first law of thermodynamics. I am not writing it repeatedly according to first law of thermodynamics because now you have come to know that it is coming from first law of thermodynamics. So what are you getting? 0 plus dw means again just like the cyclic process you have got the same result. So what is the meaning of this? I will not write the same 2 point. Means when dq is positive, dw positive. What does it mean? When heat will be given to the system will expand and work will be done by the system. Alright. And when dq is negative, next point, when dq is negative, then dw will be negative. It means that when heat is taken away from the system will contract and work will be done on the system. Alright. Means the last 2 point, it will be same as that of cyclic process. Next is coming adiabatic process, and this is as it is little bit different, so important and favorite of the examiners. So follow this. What do you mean by the term adiabatic process? Adiabatic process means the process during which total heat of the system remaining constant. Means the system neither releasing heat to the surroundings nor it is absorbing heat from the surroundings. Is that clear? So what is the first point? As Q remain constant, total heat, Q means what? Total heat. Total heat Q. It remain constant. It means the change in heat is 0. Neither the system absorbing heat nor the system releasing heat. So you see what you can write, dq is equal to du plus dw. So 0 is equal to du plus dw. So you see you are getting dw is equal to minus du is equal to minus dw. Is that clear? Very, very important concept it is. You have to understand it. What is the physical meaning? So you understand it that suppose the system is expanding. Suppose the system is expanding. Alright. Means volume increasing. System expanding means what? Volume increasing. Alright. Then volume increasing means what? dW will be positive. Is that clear? Because we know the sign convention. When the volume of the system increases, then work done is positive. So dW positive. So look at it. If dW is positive, there is a negative sign here. So du will be negative. So du negative means what? Internal energy will decrease. Internal energy will decrease. So internal energy decrease means what? Temperature will decrease. Is that clear? So what is the conclusion? Adiabatic expansion. Adiabatic expansion causes cooling. Alright. So you will get the question like this. That show that adiabatic expansion causes cooling. Then you have to write this way. Why adiabatic expansion causes cooling? Isothermal expansion never cause anything. But adiabatic expansion, if a system expand adiabatically, the practical example, when a tire burst, then what happened? Suddenly, the air within the tire, it comes out. And it comes out to the surrounding and it expands. Then what happens? It causes cooling. You will see that the air means within that one tire, it will become cool. Why? It will become cold. Why? This is the cause. Because adiabatic expansion means dq will be 0. dq 0 means du is minus dw. Expansion means dw positive, work done positive. So if work done is positive, according to this relation, the internal energy will become negative. Internal energy will decrease. Internal energy, change in internal energy, negative, du negative. What is the meaning? Internal energy will decrease. When internal energy will decrease? When the temperature of the system will decrease. Alright. So, adiabatic expansion causes cooling. The question, probable question from this discussion, show that adiabatic expansion causes cooling, or why adiabatic expansion causes cooling. Then from this point to this point you have to write the answer. Is that clear? Like that, in the opposite manner, adiabatic contraction causes heating. Alright, just look at it. I am not writing it. Just here. When the system will contract means what? Volume will decrease. So when volume will decrease, dW will become negative. So if dW is negative, what will happen to du? du will become positive. So du positive means what? Internal energy will increase. Internal energy will increase means what? Temperature of the system will increase. It means what? Adiabatic contraction causes heating. Just opposite of this one. Okay, adiabatic contraction causes heating. Purposely I have not written, because it is your duty now to listen to the lecture properly and to note down the important part. Alright, so this is the concept related with the adiabatic process, or how to apply first law of thermodynamics in adiabatic process. Next one is the isolated system. Alright, isolated system means what? It cannot take heat or release heat to the surroundings, neither heat nor energy. So you see, you can write that for isolated system, dq is equal to 0. Alright, so as it cannot take energy or cannot give energy to the system, so it cannot allow anybody to do work on it, or neither it can do work on the other system. So you can write that dW is equal to 0. So you can, as dQ 0 and dW 0 for isolated system, you know that du is equal to dQ minus dW. So internal energy of the system, change in internal energy of the system is also 0. Alright, it means what? According to first law of thermodynamics, isolated system, for an isolated system, dQ, GU and dW, all three are 0. Alright, so that's all about this chapter. That is the end of this thermodynamics chapter. Very important chapter. Please do learn all the important topics I said during my lecture. Thank you, children.